So the second method is when a parabola is identified as a modified square. Now when I say a modified square, here's what I mean. If you take a binomial like this and square it, you end up with the same factor every time. That is, x plus a times x plus a, when you FOIL it, gives you x squared plus xa plus ax. In other words, plus 2 ax's. And then at the end, a times a. In other words, every square of this form has a double. It has an even number in the center, which means if you were to have a parabola that looks like this, say x squared plus 2x minus 15, you might recognize, aha, this is a square, but this isn't. So this is some sort of messed up or broken square. So the key here is to be able to do what's called complete the square. That is, figure out x squared plus 2x. What ought to be here if it were really a square? There's some number here that would make this be a perfect square. Well, the way to figure it out is half of this squared. So what is half of this? Half of 2 is 1, which means that the next number here ought to be 1 squared, which is 1. This right here is a perfect square. You can work that out just to confirm that it is. X squared plus 2x plus 1 is equal to x plus 1 squared. But this isn't the parabola that we're supposed to be solving. It's supposed to be minus 15. So the question is, what can I put here that will turn this into minus 15? I'd have to subtract 16, wouldn't I? That is, if this ended with plus 1 minus 16, then this is minus 15, right? Yeah, so if you can recognize x squared plus 2x minus 15 as x squared plus 2x plus 1, a perfect square, minus 16, then you're recognizing this as a modified square. Okay, so what's the point of all this? Well, the point is, if you can turn this into that, then you can turn this into that. And since we're dealing with this situation, it means this is the equation that we're trying to solve. So how do you solve this? This is actually not that hard to do. You see, if you add 16 to both sides, then you can take the square root of both sides. The square root cancels out with the square, and the square root of 16 is 4. But this time, the plus or minus is absolutely necessary. Just like you need it in the quadratic formula, you're going to need it here. Remember when we were solving absolute value equations earlier in the year? We're in that same situation now. We need to solve x plus 1 equals positive 4, and we need to solve x plus 1 equals negative 4. Both times, it's the same move. You just got to subtract 1. So subtract 1 from both sides, x equals 3. Subtract 1 from both sides, x equals negative 5. These are the two answers. All of that made you avoid this. It's really a judgment call whether it's worth it, because This is a kind of tricky thing, but once you do it a few times, you get to see the pattern. The other reason why I like this is because this resembles an equation for a parabola that, in my opinion, makes more sense than this one. If you remember, B kind of moves the parabola in this like weird, well, it's a parabolic shape, and C just moves it up and down. This number in here moves it left and right, and this number moves it up and down. I think it's a little bit more logical. So, in summary, this solves everything, but it is sometimes overkill because it's very complicated, and when the answer is real and rational, it seems like a whole lot of work for something that didn't require it. This one is easy to do mentally, but this one gives you access to a form for a parabola that makes a lot of pragmatic sense. Anyway, you may have noticed this parabola was the same one that was in the previous example, the one for product of two lines. So you can confirm it gives you the same answers, and these are both perfectly valid ways of solving quadratic equations.